Today we want to look at deformation of solids. Here we have Hooke's law. Are you struggling with how to answer questions when it has to do with string and you don't know what to do? This one is for you. I want to show you how to go about it in a very simple way. Force is proportional to the extension of an elastic material, provided that the elastic limit is not exceeded. So take note of that. You can define it, but the key thing is that the load or the applied force is proportional to the extension of an elastic material. You can put it within the elastic limits. Make sure those keywords are there. The next one, the variation with the extension x of the force F for a spring A is shown. The point L on the graph is the elastic limits of the spring. Describe the meaning of elastic limits. Elastic limit is a point where a material will extend and return to its original shape and size after exposing it to a deforming force. Beyond the elastic limits, the material will behave as a plastic. It will not return to its original shape and size. Take note of that. Calculate the spring constant for spring A. For us to get the spring constant, we will get the gradients of the graph. Let's look at some points to pick out. We can use this and this, or we take the maximum. So let's pick where it is clear. We have 8 here. We have, this is 6, 7, so this will be 6.4. Spring constant equal to change in force over change in extension. That will give us 6.4 divided by 8 times 10 to the power minus 2. The answer is 18. We have here 18. Take note of that. You can pick any point, but make sure it is very. Calculate the work done in extending the spring with a force of 6.4. Work done in extending it to 6.4. Luckily for us, that is where I picked, so it makes it easy. Work done is the area under the graph. Area under the graph. So we have a few formula. Area under the graph can be half Fe or can be half Ke squared. The one that you feel comfortable is the one you use. But the two of them can still give you. Let me quickly use the two of them so you can see we give you the same thing. 1 over 2, the force is 6.4 and the extension is 8 times 10 to the power minus 2. Put this in your calculator. Let's also look at 1 over 2 times spring constant is 80 and the extension is 8 times 10 to the power minus 2 all squared. Let's see what will give us. You can see that the two of them give us 0.256. You can use any of them once you know what to do. Alright? The next question, a second spring B of spring constant 2Ka is now joined to spring A as shown. A force of 6.4 extends the combination of springs. For this combination of spring, calculate the total extension. We have two ways of calculating the total extension. Either you calculate each of them and add, or you find the total spring constant. So let's start with the one here. The spring here is 80, the spring constant. While here for B, they say it is 2Ka, which means 2 times 80, 160. Extension, total extension will be extension in A plus extension in B. This will give us, formula for extension is force over spring constant. This will be 6.4 over spring constant for A is 80 plus 6.4 spring constant for B is 160. This will give us 0.08 plus 0.04, which is 0.12 meter. The total extension is 0.12. The total spring constant Spring constants total when they are connected in series, we use 1 over k. So this will be the formula. And this gives us 1 over kt equal to 1 over 80 plus 1 over 160. 1 over kt will give us LCM is 160. This will be 2 plus 1, 3 over 160. Kt will be 160 over 3. The answer will be 53.33. 53.33. This spring constant question, sometimes students don't know. If you have any question, or if you want me to solve any question under this, let me know. I will solve it for you. We come to the end of this deformation of solids. Before I end, let's go back to it. We mentioned Hooke's law. I used to remember Hooke's law. We mentioned spring constants. We find it using the gradients, and we check the units to ensure that we use the right thing. We mentioned spring constants. We mentioned elastic limits and spring constants. We noticed that we were asked to find work done. The spring was connected into 2. We were asked to find the total extension and the total spring constants. If you have any question, kindly drop in the comment section. I will attend to it. Bye.